All right, what is up, guys? Let's today set up a basic CNN neural network to do the MNIST data classification. All right, so this video has gone on extremely long. So if you just want to see the code, I'm going to put it in the comments. The code's what you need. The code will be running good. Throughout this entire video, I try various different things. And by try, I mean I forgot to type certain things, forgot to remove certain things. Mainly it comes down to the model setup. I forgot to increase the filters as we go along, and I forgot to change the input shape. Also, the compiler, the fitting of the model, it takes a little bit of a long time since I'm not connected to a GPU on this separate machine, not the one that we're going to be doing things on. So I apologize. So let's get to it and start with the imports. All right, so unfortunately we do not have access to GPUs on new notebooks, but it looks like if you copy the Google Colab tutorial notebook into your drive, you get access to the GPU so that this works. I guess they don't have a choice. So hopefully if I share this with you, you will still be able to have access to the GPU. If not, then that's too bad. But either way, it's good to go through this. And since this is a very basic tutorial, you might as well see this. So this actually is a win-win for everybody. So quickly, it's a virtual machine. We can do command line stuff with the exclamation point. This is just going to show the directory, long form. It's going to give you the date and all that. Print the working directory. That's just going to show you where you are. Same thing here. This is going to just, cat just shows a small portion of this file, or the head of it. And then NVIDIA SMI, that's going to be our GPU information. We got a Tesla T4 with 15 gigabytes of VRAM. Then we got GPU stat, fair sec, and build essential. These are Ubuntu tools. I am on an Ubuntu machine. I'm actually on Ubuntu 22.04. This is 18.04. That is before my time, but it is a popular one. It seems like a lot of stuff is built around this Ubuntu version. GPU stat is going to be similar to the NVIDIA SMI output, except with we're gonna you get temperature here, you get percentage used here, and you get the ratio used here, and you get the ratio used here. It's all the same. I like NVIDIA SMI because it will show you the processes that are running. It's good to know. It is what it is. I don't think GPU stat's going to do that for us. So here's some Python information to see what kind of Python we got going on here. This is one way to do it. You can also just do the command line, Python version, just like this here. And we can mount, so we can upload data. We might end up doing that. And all of that stuff here, it's just more of the same here, and just more commands that we have. wget's gonna let us get things from the internet, just more of this. Here's some code that's gonna, nothing really important resources. Those are good to have, so we really can't lose. All right, so that is the workaround that we are going to use for this tutorial. Let's get to the imports for real, and start coding. All right, it was a little bit quiet there, but you didn't really miss anything. It should all be on the Colab. Anything you're questioning, you should be able to Google and do just fine. I do have videos explaining neural networks a little bit more in depth, so this will mostly be a how-to as opposed to a how done or why done, so let's get these imports in. First thing we should do is import numpy as np. That is just the package for numerical operations. Make them a little more efficient with Python. It's just a classic. Everyone's using it. Always has been used. Big up numpy. They import it as np, so you can do np dot absolute, instead of writing numpy every time. It's just a little more convention at this point. And then we want TensorFlow, so we're going to go ahead and import TensorFlow as tf. TensorFlow is going to be our machine learning library for the deep learning that we're going to be doing, because we are making a deep learning convolutional neural network. A convolutional neural network, which is an application in deep learning. It's convenient. When we name it as tf for the same reason we do, what else? We want matplotlib to visualize things, so we're going to go ahead and matplotlib.pyplot. There's also Seaborn. That is pretty much the same thing, but we're going to go ahead and use matplotlib. And then we're going to go as PLT for the same reason as above. And we also need Keras, which is part of TensorFlow as of, maybe 5 years ago, really, or maybe 4 years ago, 3 years ago, sometime before now. And Keras is going to be an API that's going to let us, get some easier functionality, make things a little cleaner and better to use. And I'm actually going to put a little enter there so we can have all of our Keras stuff separated. need. And we got to get the layers that we want. So from Keras layers, we're going to import the activation layer. I don't think we're going to need that. The activation layer is, or not the well, I guess it is, but the activation function is going to be the ReLU. That's what we're going to end up using. And that is going to be the function that we modify to get the curve to fit, which is what we're doing. We're just creating a curve that fits, sort of. It's not really a curve because this is pretty high dimension. But it, some kind of thing that fits the data. So what else? We need, actually, yeah, we were going to make a sequential model. So let's do that first. Keras models, import sequential. I spelled import wrong. That's models, import sequential. It is a sequential model. Unlike the transformers or the recurrent neural networks, this just goes layer to layer to layer to layer. A recurrent neural network will do some back steps. The transformer will do all kinds of stuff. We're all over the place on a transformer, but we're not doing any of that. This is just a basic CNN. And let's go back to the layers from Keras dot layers import vation, dense layer is going to be the fully connected layer at the end. Flatten is going to take the convolutions. As we proceed through the convolutional neural network, we'll get a pretty long block of stuff, pretty high dimensional piece of information, and we're just going to kind of smush that down into something that can get passed through in a way that makes sense. Batch normalization, that is going to be just it normalizes the activations of the previous layer. So the activation functions are going to be multiplied and added by various values, the ReLU line, and those can go all over the place. So we want to kind of put them in a range so that they kind of make sense together. And the conv2D, that is going to be our 2D convolutional layer, which is what we basically want. We're going to have an image and it's going to convolve over the two-dimensional space. That'll, if that doesn't make sense, I'll probably put some graphics up so you can kind of see what that looks like. And then max pooling, that is going to be the way the convolution is calculated. So the filter is going to go over the portion of the image, and we're going to take the maximum of that value as it passes over the image. Again, that'll make sense as we go along. And then we need the optimizer. This is going to be the mathematical algorithm that we use to facilitate backpropagation. So we're going to do, well, I guess keep it up here, from keras.optimizers import, I think it's just capital Atom now. That's how they do it. It changes quite a bit, so that may not work, and we'll fix it. We'll just Google it. There's like an Atom v2. There's a bunch of atoms. So that's what we got. Then we need metrics so we can actually make sense of how the model's doing. So that's also in Keras, from keras.metrics import categorical cross entropy. This is going to be the loss function, so we can make sense of how far away the model is from the truth. We will have the truth and we'll have the model's prediction, and this will help us, in combination with Atom and back propagation, we will be able to train the model. You don't really need to know what that is because it will happen automatically. All of this is pretty much plug and play at this point. And then there's some pre-processing. We really don't need pre-processing here because this is just going to be a black and white image that's 28 by 28. But if you want to do another application, you can literally use this same code for pretty much any image classification. Not object detection, but if you want to classify an image as maybe, let's see, we have to keep things appropriate. Maybe, wow, I literally cannot think of any PG classifications. Cat or dog, you want to, is this a cat or is this a dog? There you go. Oh man, I really want to say what I was thinking, but I can't because, it's inappropriate. And apparently, people, I don't even know. I don't even know what's going on with the world anymore, but that's just what it is. Image data generator. This is just, so, we can actually, when we make the data set, we can do a lot with this. We can resize the image, do shifts. We can expand our data set. So if we have a data set of images, we can use this to maybe change the hue of the images, maybe rotate the image a little bit, make the classification task a little more complicated so that when we're training, we're getting better results with more data. Okay, so then we're gonna do sklearn stuff so we can get so we can view the training results. We want a confusion matrix, so we're gonna go from sklearn.metrics import confusion matrix, and a confusion matrix is a type of graph. In this case, I think it's 3-dimensional, and it's going to just show us the predicted on the Y and the actual on the X. Maybe it's flipped around, and then the color will represent the strength, how many of those were crossed. You'll see the confusion matrix, so don't really worry about that. But that's my favorite viewing of at least image processing results. It's the easiest to view. I don't think there's much better than that. There's some graphs, even the PR curve it's hard to make sense of, and even if you get a good curve, like what really happened, you don't know. So the confusion matrix is the simplest. So and then we're going to import iter tools. This is just going to be it's just a library for, we don't need this, but it'll do things that may be useful. So we'll go ahead and keep that. And that should be all of the imports. Let's see what we got. If we don't have anything, we can pip install. We do have pip available to us. So we'll go ahead and run this, which is Control Enter, and we're good. Imports were successful. Fantastic. All right, so let's move on to just building the model. The model is going to be very short. I think I'll do maybe 5 layers. The input, a couple convolutions, and an output. So maybe 3 convolutional layers, input and output, 5 layers total. So it is a different day. Maybe I can just... So it is a different day, different camera angle, different clothes, same guy, same code, same thing. We're going to be doing the Kaggle digit recognizer competition. I don't expect to get above, I don't expect to get 100% accuracy. We could try though. So we'll do 4 convolutional layers, see if that improves. I think with 2, we were getting 98% accuracy, but doesn't really matter. So here we are, back here. I have ditched the original notebook I was using because I'm on a different setup, and it should be fine with that. We're not, this isn't going to break the bank here. So we got our imports here. We should be good with those. We're going to import other things as we go along, pretty much in every cell, so we can run every cell independently. Again, this is just to make sure that we have things available to us, and we don't have to do any pip installs or anything like that right off the bat. So let's create a new cell. Let's build this model. It's going to be a straight sequential. Model equals sequential. We'll go here with that, and we'll just start right off the bat with a conv2d layer. Filters, we're going to go 32, kernel, I'm pretty sure I explained this earlier, kernel size equals 3,3. Activation, I did definitely explain this. This is the ReLU. That's the most popular, the simplest. It's good stuff there. Padding, we're going to go same. We're not going to go outside of the image. We're just going to keep it in the image. Input underscore shape is 28, 1. This actually is a CSV file and not a image in that sense, but we can still reshape it'll all just work out. We reshape the tables in this way, and we kind of iterate over the tables. It's all data, so it's not actually tables. It's all ones and zeros. It ends up being the same thing. The computer doesn't know what's going on. Max pool 2D. This is the pooling layer for the convolution. This is how the convolution really happens. And so we're going to do a kernel size of 2,2 of the kernel. So the kernel, we're going to take I explained that earlier. So for the 3x3 kernel, we're going to go 2x2 over and do a little max pool on that bad boy. Strides equals 2. So we're going to hop over each one. I don't know if we call that skipping, but that's how far we're jumping over. And we're going to do that again. Well, it ran, so that's good. I shouldn't know there's a comma there for no reason. But we'll go ahead and do that. Yeah, I forgot to take out the input layer. That's going to be an error. Just make sure that you take out the input layer for all those other layers except for the first layer. The only layer that should have an input layer specified is the first one. Comes out as some kind of long object of various numbers and we're going to smush that down. That's not really what's happening. We're just going to change the number format to reshaping basically so that it can go through the dense layer, which is the final layer, which is going to have the predictions for us. The final layer is going to be 10 nodes, I guess, if you want to think of it that way. 10 nodes, and whichever node has the highest probability, we're going to one hot encode and say that that's the answer. If that doesn't make sense, I have a plethora of videos on that somewhere. This is just for those who just really want to get things going here. And this is basically how you do it. So let's just make sure that runs 2 by 2, 3 by 3. Everything should be the same. 3 by 3, 2 by 2. Soft max, activation, dense, unit. It should be an S there. Okay, cool. So we have set up the model. We're going to do 4 convolutional layers. Is that going to improve things? Maybe not. It might actually make things worse because it's a pretty simple set of data we're working with. But let's just see what happens. 2 layers, I know for a fact we got 98% after 30 epochs. So let's see what 4 does for us. And I do apologize. This is going to be raw as road rash, but we are just going to get things going. And if you want to see what the model looks like, for some reason, this is not enough for you, you can do a little model summary right here. Go ahead and run that. Control Enter is also something that works. And there you go. Parameters, a bunch of them. Trainable parameters, same amount. Non-trainable parameters, none. So we're good there. That all looks very good. Nothing to complain about. Now, we're going to be doing the digit recognizer from Kaggle, so we do want to download this whole thing here. Nope, not the sample submission. We want to download everything. So we'll download all. It should give us a little zip here. And let me set that up for you, and we'll be right back. I guess I got to show the process because it might be a little confusing. So we want to extract that. We got it. And then we're just going to put it in Google Code, in the Google Drive. I should have a folder called something. I don't. We'll make a folder. Classifier. Is that how you spell it? No, okay. MNIST classifier. There we go. There's a folder. And we'll go ahead. Take that. Put it in there. Digit recognizer. Drag it in. There we go. Cool. Oh, it was still uploading. Okay, my fault. Alright, so it is there. Cool. Okay, so for future reference, we can pretend that we don't know what this data looks like. We've got a trained CSV. We're going to open it up with LibreOffice. That should all be okay. This is just Excel for free. And worse in every aspect. Just really poo-poo Excel. Not really. I don't really use Excel, so I have no idea. It's confusing. A lot of tabs. I don't really like it. Okay, so this is the train, and let's open up the test. See if we can notice any differences here. Go ahead and close out of that. And there we go. Okay, so the train, this is the test here. There's no label in the A column. If we go here, it's just the pixels as is specified. And we just have no label and all the pixels. As you can see, it's a CSV, but an image would be processed exactly the same way, just in a different format, way more pixels, larger. But yeah, we want to normalize these values between something less than that. So these are going from 0 to 225. We don't want that. So we're going to change that. We're going to do some normalization. In the train, we do get a label, and the label is the correct digit that we are trying to identify, and that's going to be helpful. But when we're actually passing it through, we want to separate those. So the X will be the data, and the Y will be the truth or the value. So we'll split that up and get to it. But that's what you want to do. You want to analyze your data before you get working on it. So that's how you would do it if you were to do it. But it's going to be the same for this classifier. So we really didn't have to do that, but we did. All right, let's get to pre-processing this. We got to separate these, normalize these values, and make sure that we one hot so that when we make a prediction, we're just predicting the highest confidence and not trying to do some kind of averaging or something stupid like that. All right, let's get to pre-processing the data. We are going to be using pandas for the data frame. Once we actually haven't uploaded, or I guess we did. So it should be in Drive here, my Drive. Should be a folder somewhere called MNIST classifier. There it is, digit recognizer in that folder. And praise Jah, we can copy the path. That is one thing Ubuntu is really lacking, but whatever. Forget that, just remember that that's there. So we want to import pandas as PD. That's convention. That's what we're going to be using for the data frame. Ultimately, we're going to be using a TensorFlow data set, but this is going to make it easier to work with when we're getting the columns out and reshaping and doing all that. And we want to import TensorFlow as TF, and you're going to say, hey, we already did that, but I think you should have imports periodically throughout the notebook so that you don't have to run the entire notebook every single time you want to run a cell. which a lot of notebooks nowadays are doing that. They put all the imports at the top. You have to run the whole notebook, and it defeats just make it a Python file at that point. So this is kind of one, this is a little, I guess you could run the import cell and then run the specific cell, but it's annoying. And it doesn't cost anything to type these out except for time. So, I don't know, maybe it's to each his own. So those are what we're using. Two categorical. That is going to be how we set up the one hot encoding, which is what we're going to end up using for the training and all that stuff, and the actual prediction in the end. But just to set up the model. So we're going to call this train data frame. DF is the convention for a pandas data frame, and we're going to put train in front of it so we know that it's the train one. There is a test one coming up. Read CSV, and here's where this comes in. We're going to use the train CSV. That's what would make sense. Copy that path, and we're going to put a little thing here, paste it in there, and there we go. We probably should rename that. I don't like the space in there, but it handles spaces pretty well, so that's fine. All right, so how do you remember iLock? You just kind of go into Gemini. We'll try out Gemini below in triple asterisks. There's a lot of ways to kind of help these models understand things a little bit better. Yeah, I guess. Well, I hit enter. It wasn't a control enter thing. So there we go. This is going to get into the selection of columns and rows using iLock indexing. Represents all rows and selects the first column, index 0 only, and we can go back here. Similarly, this is going to do the same thing, except select just the first row. Let's see if it'll pick this up if we just type that in. All rows and columns starting from the second column. This comma is going to tell you that, and then this is going to tell you that part. That's basically all you need to know. Yeah, so there you go. That's the iLock. Now we want to actually do some pre-processing. We want to reshape and normalize because we do have those values. I don't even think we're actually normalizing anything. So we're going to go x.reshape. And really, you just need to know the process, and then you can go ask a higher power to do this for you. That is the power of these GPTs. It seems like people are having trouble getting these things to do anything, and it seems that you're not actually, you have to have the steps. You got to know, a little bit, and then ask it to do this. Just be like, hey, I need to reshape the image, 28 by 28, and I want it to be a float 32. That should normalize everything. It already is going to be a float 32. We could probably put that down to an int 16. We could just make that an int, really, but that's fine. Okay, so we're going to reshape that. And then y, this is where the one hot encoding comes in. You got to know what one hot encoding is, and then just say, hey, I want these outputs to be one hot encoded. Two categorical, and it'll be like, all right, I got you, my dude. And it got you, my dude. Two classes equal 10. You want a one hot encode, it just makes things better so that it only picks one class. That's the best prediction. If you don't know what one hot encoding is, look it up. It's like that's from back in the day. You got to know that by now. X train, comma X val, comma Y train, comma Y val, equals train underscore test. And this is just to set up the X training and the X validation and the Y training and the Y validation. Remember, the Y is just the labels and the X's are the data, and we want to have a training and validation set that's from the training set. Then we have a testing set that's outside of the training that we then test on to make sure that things are going, properly, or just to actually test it and to see how good the model really is. If you just use the validation, you might have results that are worse than the results that you are actually working with. In this case, that shouldn't really be the case because it's all the same type of data. But if you were doing an image situation and you have a data set of images from one source that you're training on, you'd want to make sure that your test data set is from a different source, kind of somewhere a little bit different. If you got images from one day or something like that, or one set of images or one Google search, you want to try and find a testing set that's a little bit different to make sure that things will work in production as you want them to. The random state doesn't matter. That's just going to be able, so you can reproduce this. Actually, no, that's the seed. Yeah, it is the seed. Okay, so that was the seed. My fault. That's so you can reproduce it. Same split every time. We should be doing an 80-20, and that is what the test size is. Test size, even though it's a validation, just pretend that those are the same thing. You can call it whatever you want. Okay, and then train data set. It's the seed. When is it the seed? It's the seed with sklern. Well, that is Sklern, so I don't know when it's the seed. Sometimes it's the seed. It's the same thing though. It's just to make sure that the numbers are the same, so that when you run it again, it runs again. We call this train data set case one because we are doing 3 cases here. tf.data.data set dot from underscore tensor slices. Oh Lord. And then Jesus Christ, because we're it's you gotta do it like this: X train, comma Y train, and then Y, because it's gonna be it's just how it is. And then we want to do the batch 32. That's how many are going to be passed per epoch. We're going to do 32 images per epoch. So that's going to be the batch. And it's going to batch up the images into sections of 32 to quickly pass for training. Valid data set case 1 equals tf dot data set from tensor slices. Same nonsense here. We want to make it a tuple. I'm not sure if it's actually a tuple because this is all the names are always different. That's the only thing with Python. There's no kind of uniformity in what things are called. So who the hell knows what this is called? I'm going to call it a tuple, but it's probably not. And, if anyone's paying attention, and knows the answer, they're probably not watching this video anyway. So that is what we're trying to do here. We want to get the labels out of the data that we're going to be training on. We want to put the labels in the variable that we're going to be comparing the one hot encoded values to. And then we want to reshape this so that the string of things is in a image shape. It's going to be so we have an array in the data set, and we're going to reshape it into a 28 by 28 image as type float 32. And there you go. That's all that. Good to know this, though. This part's important. You want to know these steps here because you're going to have to, if you know these steps, you can tell it to do this for any data set. And GPT, Gemini, or whatever higher power you're using will be able to spit out something for you pretty good. If you don't know this, it's going to try and do too much, and it's going to cause all kinds of problems, which is probably what you're facing if you're watching this video. All right, let's compile the model with one line of code here. Model dot compile my finger's numb because I tore a tendon again, or I got the A2 climbing tear tendon thing. I don't know if you've heard of that. Keras dot Keras dot optimizers dot atom with a learning rate of 0.0001, and atom is going to be how we do our gradient descent. It's going to update the speed of changing values, or the amount that the values are changed per parameter. Basically, it's going to make things converge faster than if we didn't do that, and it's the simplest and best one, that the easiest one, basically. And we're going to do loss equals categorical, and my finger is really numb, cross entropy. This is just going to compare. That's why we want hot encoded. So we are going to get a probability of values across the 10 nodes that we're predicting on, and we're going to compare what the model predicted, which is going to be, maybe 0.9 for one, 0.7 for the rest of them. Probably not, but maybe it is. And then we're going to compare that. Let's say the actual decision was 2, and it's going to compare 2 will have a value of 1 since it's one hot encoded, and it'll be way off because it gave 1 a 0.9 and the rest of them 0.7. So then we can see that. We can then update the parameters with Atom by some amount that Atom has decided, and we can move on from there. There's a bunch of ways to calculate loss, but for this case, for classifications, categorical cross entropy is not a bad way to go. And metrics, we want to base this off accuracy. And that should give us a good little compiling. We forgot to run that. Probably it's fine. Okay. All right. Again, this is super raw, and this video is pretty long. It's already like 30 minutes, but let's fit the model. We're gonna just use what we've defined. Train data set case 1. That's the X. We already defined that. Don't need to explain it. Steps per epoch. That's how many pieces of information are going to be going through per epoch. And we want to do everything. And remember, we batched them into groups of 32. So we're going to do however many batches of 32 per step for the whole epoch. And we want that to go over the entire data set. So we want one epoch to be one pass of the whole data set batched up into groups of 32. So len train. I'm pretty sure I have a video explaining all these terms here. There's a lot of terms, but they just put words in there to you know, it's I don't know. I like to say like tennis. I don't know if you've played tennis before, but the scoring in tennis is purposely stupid to just flex on people that don't know it. And I think pretty much everything is exactly like that, just to flex on you. uh, People like to flex, and it's the same thing here for the validation. And there we go. Train data case one spelled something wrong for sure. Train data set and is not enough because we want to specify the epochs. I'm going to go 30 epochs here. 30 epochs is how many times are we going to go through the entire data set. And we're going to do that 30 times. And verbose is just going to be a level of how much output. The verbosity, it's just a word in English that means how much words are in the words. So we're on that. Let it go for 30 epochs, and I will come back, see how it does. All right, so for this first case, Kaggle has a specific way that they want this data to be set up. So we're just going to go ahead and code that up real quick. You don't need to see this because, no, you really don't. All you are going to really need is the predict. Predictions equals model dot predict x test. I guess we'll do this whole part. So we'll do the initial part, and then I'll add the code to set up the file, and then we'll do the other cases so that we can actually see results. Whoa, somebody messaged me on Discord. That never happens. That's awesome. So import. Nobody messaged me. Damn it. Never mind. Import numpy as np, and then import TensorFlow as TF, just so we can run this cell individually. Let's turn that off. I don't know why I responded. That's a good dude. There's good people out there. I don't know if he's a good dude, but he's chill. He had no problems with him. Discrete math, man, yeah, I don't know. It's a class. df equals pd dot read CSV. It's a good class. You probably should not drop that. But whatever. Okay. They actually honor coded me because unfairly. Someone didn't do a project, and I, asked them. I said, "All right, if you want to get credit on the project, throw me some cash." They did not throw me cash. They did not get credit on the project, and then they reported me, and I don't know what happened. I never saw them again. And I'm not gonna, pursue that because I don't want to, they'll report me again. But I guarantee that he probably got credit for the class, probably through crying or something like that. And they just completely screwed me over. So I had to take that class again. That's just how it goes in the struggle. Anyway, so you want to divide that by 255. Because it's just kind of normalization. Those are the values that we have. So we want to divide each one by 225. So we're in the range of -1 to 1 or 0 to 1, depending on how it's set up. It should just be 0 to 1, I guess. Maybe it's -1 to 1. Not 0 to 1. And there's kind of normalization there, something a little pre-processing for you. And then those are the predictions. And then we will go predicted labels, and we'll go np.arg max. And that's going to take the arg max. It's basically the one hot encoding of the predictions. That is one hot encoding basically. So the one hot encoding that we did above for the labels, this is going to take whatever prediction we have. The argmax is going to take the highest prediction and send that to be the label. So if we have 0.9 for one and 0.7 for the rest, it's going to take 0.9 and the label will be 1. So there you go. And then we'll go predictions, axis equals 1. And that's just going to, what? Didn't I already type that? I feel like I already typed that. No, I didn't. That's the argmax. That's the argmax for the axis equals 1. Okay, so we're good there. And then submit. I did type it, but I'm typing it again now. Submission underscore df equals pd dot data frame. And this is just this is the whole thing. This is just to create the file in this format. I don't want to waste too much time going through this. We're going to have 2 columns, one for the image ID, one for the label, and we're going to take this from the predicted labels, and we're going to call this the image ID is going to come from the prediction, and then the label is going to also come from the prediction, but be the thing that we just set up there. So I'm going to do that, come back, and then we'll do something else that we can actually view. Whoa, big time correction. The input shape definitely should not be 28 for each one. That is a big no-no. We want the input shape to be whatever the hell the input shape is. Because the convolutional layer, the shape of the is going to be, who knows what the hell it's going to be, but definitely not the same as the image. So that was a big time mistake. essentially that was just taking what we had and making it one layer. So we just wasted all that time. Let's try it again with 4 layers again. We might see something better. Why was the training and validation so good? I couldn't tell you, because 1 layer is probably enough because it's such a simple task. We could do this without a CNN. We could maybe do it just going straight. Nah, we couldn't go straight to flatten. We need something, but we could do one dense layer up here. We could probably do a dense layer up top. Do dense layers, input, not even reshape it. Just do a dense layer with whatever the input is, maybe 1 by however long that thing is. It'd probably work. It's a simple task, not that hard. They figured this out quite a long time ago. So we'll try again here. Didn't compile the model there. Let's go ahead and compile this. We'll run this, and I will return. I bet we get better results. I'm cooking some soup now. Very excited to eat that. I'll post these results, and then I'll post the video. Or I guess while this is training, I'll do the other stuff, and we'll come back. This is too long. I've been making soup lately. Pretty fantastic. All right, this is case 2. I'm actually just going to upload the other one that I have that was on the original one on my other machine. So you don't really need to know this. Nothing really to explain here, except we split the original data set into 2 halves, one with half of the images, the other with the other half of the images for testing. And when we do this, we actually have all the data with labels, so we can do training on 1 half and come back with something that we can actually look at and see when the results come in. So once this is done with the epochs, there's 3 left. I'll show you the confusion matrix, which is fun to look at. Another error. I'm going to post the actual code. You can see that the filters, I didn't update the filter size. As we go through, and we got to increase the filters as we go through. Really, we should go 64 and then 128. And we can just keep it there. You can then do another one. Well, 256, why not? 256. That should be better. So we'll run it one more time, and then the video is over. So the next thing you're going to see is the results, and they should be better. But yeah, my bad. I get 98%. I am eating soup. I don't even think I'm going to post this video now because there's so many errors. But I'll post the video and the code. The code's really what you care about. Just make sure you get the filters right. All right, we're basically done here. Just trust me, it works. Go to the code down below. Open that up. That'll tell you everything you need to know. I had some soup. It's delicious. I'll be doing a bunch of these more often, but I'll do real videos also. But I'll probably just stream this in the future. I don't know how long this is going to take to upload, but I'll be posting all this kind of code because apparently, people are struggling, which makes sense. This stuff is, you got to type it, and it's a lot of typing. I've been doing this for quite some time. People don't believe me. That's fine. I do just look like this, but, that is what it is. I will get better at this. This kind of stuff is good to refresh myself on. I gotta redo a video really on the optimizers and gradient descent because that's a topic that's going to be coming up pretty frequently, pretty soon. It's basically calculus, except I guess it's like higher calculus, but you don't have to know any of that crap to use it. It's just you just type it in there, but it does help to know what is happening, sort of, so that you can understand learning rates and things like that. So we'll get to that. I hope you like and subscribe. I know this video is long and garbage, but sometimes I put on a long video that's kind of garbage, and I just type along with it and have a good time. Eat some soup. I've been eating soup lately. Pretty delicious. You just put food in the boiling water and you boil it up, and it's fantastic. I hope you have a fantastic day. Hope the sun is good. Hope water is delicious. Praise Jah. We gonna make it. There's hate out there that I contribute to, and I do apologize. But it's tough. Some people, it's just tough out there. So I apologize. I hope the hate, is not persistent. Even and if it is, that's too bad. That's just how it goes. You can't control people. So do what you want, but I hope you feel good doing it. Peace.